Hey, welcome back, weebs. We are going to talk about binomial expansions today. This is actually the second time making this video. Unfortunately, the first time I was like 3 minutes into this video and someone knocked on my door and my dogs freaked the heck out. So rather than just murder every single headphone user in the videos, I'm just going to make a new one. But Mr. Bot, why didn't you just edit the video so that it didn't have that sound? Listen, then I have to go learn how to edit videos. I'm sure it's not that hard. It's probably built into the software, but you know what I mean? It's 3 minutes. It's not a big deal. I'm not going to trip about it. You don't trip about it. No one's tripping about anything. All right. So what we're going to learn today are binomial expansions. So this stuff is actually something you learned in Algebra 2. But I'm willing to bet that your Algebra 2 teacher, not going to name any names, definitely all super great Algebra 2 teachers, doing a quality job educating you guys, doing a good job. But it's something you got to learn. So we're going to learn how to expand some binomials. So let's talk about what the problem is and why we want to solve the problem, right? So a binomial is just one thing plus another thing. A and B could be anything. They could be numbers, they could be variables, they could be, whatever you feel like making them. And then we're going to put them to some power. We don't care as long as it's an integer like 3, 8, 19. We want it to be 0 or higher. So no negatives, no fractions, none of that funny business. So if you wanted to do this problem, you have to do a plus b times a plus b times a plus b. And you have to do that however many times n is, right? So if n's 8, you've got 8 of these things. So then you got to FOIL this thing, and then you're going to get a plus 2ab plus b squared, right? And then you got to take this thing, and then you got to FOIL it with this, and then you got to FOIL some more, and you've got to do that, like 9 times? No, thank you, sir. So luckily, mathematicians are geniuses, and they figured out a sweet pattern that we can take advantage of so that we don't need to sit and multiply ourselves to death. I'm going to show you two different ways to expand binomials. One of them is a fancy pyramid thingy that you've definitely seen before. And I'll show you how to make it and where it comes from and whatnot. And then I will show you a formula. Now, when we're looking at these two things, you want to keep in mind that if you're cutting up vegetables, you don't walk into your bedroom, reach up onto your wall, and take the sword your parents bought you for Christmas last year off the wall, sharpen that thing out back on the grindstone, start slashing bamboo with it just to make sure it's sharp, and then come in and cut up your celery, right? You just walk over to the knife rack, get your paring knife, and you slice that stuff up. Likewise, if you're defending your nation from Mongolian invaders, you don't go get a paring knife. You go get that sword, boy. You give them the beats, So just be aware. Different tools for different situations. If I give you something easy, like x plus 3 to the power of 3, you probably don't want to go grab that equation. Just use the triangle, okay? But if I say you have 4x plus 9 halves to the 27th power, and I want to know what are the last 8 terms. Bruh, don't make a triangle. The numbers are going to get crazy anyway, and don't even formula. Okay? So realize there's a tool for every job. Use the appropriate one. All right. So let's look at the formula. And I know some of you guys just let out a little, oh no, right? Little sigh of exasperation. But don't worry, Mr. Barton's here. I'll hold your hand. You're going to be fine. So let's look. This is the binomial thing I just told you about. This is the problem, Okay, so don't trip about this. This is your problem. We have a plus b, and we want to multiply it to itself n number of times. Cool. Here's a formula for that. And this formula is maybe a little scarier than it needs to be because we're trying to show you a pattern that is happening. So let's dissect this formula. The first thing we want to look at are these things here. These things are going to be coefficients. Let me write that out so the people who are listening to lo-fi know what to write. These are coefficients spelling. Cool. And the way you find these coefficients are by doing combinations. Remember yesterday, I showed you guys like 8 different ways combinations can be written. The one that I think your homework shows you is this, right? This pretty little subscript C subscript thing. This is nice because it says N, choose R. It's very clear what you're doing, okay? For some reason, everyone likes to write it this way for this formula. And that's fine, okay? We can read uppercase and lowercase letters, right? We can read Times New Roman and Arial. Just because it's in a different font doesn't mean these mean different things. Don't trip, okay? So these things are just coefficients, and the way we get those coefficients is by doing n, choose 0, n, choose 1, n, choose n choose r. So if we know n and r, and they're just going to tell them to us, we just throw them into this sweet formula and it'll spit out the number, right? Number. Okay, so don't trip. These are just numbers where we plug in n and r into this formula and it spits it out. Most of the time it's pretty easy. Okay, so we got our coefficients handled. This, and this are going to be coefficients. Then let's look at this little piece after it. This is a to the power of n, b to the power of 0. Cool. This is a to the n minus 1. All right, so anytime I'm confused about something, I like to plug in numbers, and that helps me get a grasp on this thing. So let's pretend n is 3. A nice, big enough to be interesting, but small enough so that it doesn't hurt. Be good, you guys. So if this is a to the power of 3, b to the power of 0. Okay, cool. What's the next one? A to the n minus 1. So 3 minus 1 would be 2. B went up 1. So they added 1 there and they took 1 away here. This pattern will continue. The next one will be A1, B2. You're slowly transferring your exponents from A to B. And you should always have a total of whatever n is. So 3 and 0, if you add them together, that's 3. 2 and 1, that's 3. 1 and 2, that's 3. 0 and 3, that's 3. So you are going to slowly transfer your exponents from A to B. A starts with n, B starts with 0, and you'll end with A having 0 and B having n. Cool. So there we go. That's how the formula works. Let's go do an example so that you guys aren't too scared, right? Let's plug in some real numbers in this bad boy, and then we will find our cool binomial. It's actually not going to be a binomial. We're expanding the binomial. It'll be like a quadnomial or whatever the heck you want to call them. All right, here we go. So here's the thing we're trying to expand. We're doing x plus 3 to the 4th power. So if we want to do this the long way, this would be x plus 3 times x plus 3 times x plus 3 times x plus 3. This is not what we want to do. This would take a while. So we're going to use this sweet formula to figure out what this is. What you need to do first is figure out what is n, what is a, and what is b. So n is our exponent. Okay, that's 4. A is just whatever this first term in front of the plus sign is. So that's going to be x. And then b is whatever thing is after the plus sign. Take the sign with it. So b is going to be a positive 3. All right. Let's start plugging stuff in according to this formula. So we're going to start with n, choose 0. N is 4. So this is going to be 4, choose 0. Okay. Times a to the power of n. So this is going to be x to the power of 4 times 3 to the power of 0. All right, that's our first term. Now we move to the next one. So this is going to be 4 choose 1. Sorry, we don't need a, there's no fraction bar there. 4 choose 1. Decrease our exponent by 1. Increase our exponent by 1. Okay, plus 4 choose 2. I did it again. I keep trying to put fractions. 4 choose 2. Decrease our exponent by 1. Increase our exponent. All right, almost there. Next line. Actually, let me just scoot this stuff over. Okay, scoot that over. There we go. Plus 4 choose 3. Do you see me almost write the bar? Decrease our exponent by 1. Increase our exponent. And then last one, let's see if I can sneak it in there. Watch this. I'll make skinny lines. Plus 4 choose 4. X to the power of 0. 3 to the power of 4. Oh, I almost did it. 4. There we go. So there's all of our terms. Okay. So we've got all of our terms written out. This is expanded. Now we just have to simplify this. All right. So 4 choose 0. We're going to plug these two numbers into this formula here. So 4 factorial. Okay, I can do that. So we're going to have 4 factorial over 4 minus r. R is 0. 4 minus 0 is 4 factorial times r factorial. 0 factorial. Okay, 0 factorial, this is just 1. So that thing goes away. All right, times 1 doesn't do anything. And then 4 factorial divided by 4 factorial, those cancel. This is 1. So any number choose 0 is always going to be 1 because this thing will happen. The 0 factorial is 1, so it's not important. And then you're going to have the number over itself. So the first one is always 1. For a similar reason, this one will always be 1 as well. But we'll get there. All right. X to the 4th power. So we've got 1. X to the 4th power. 3 to the power of 0. Anything to the power of 0 is 1. So times 1 doesn't do anything. There you go. Your first one's simplified. It's x to the 4th power. Sweet. All right. Now we're going to look at this one. So we're going to have 4 choose 1. So this is going to be 4 factorial over 4 minus 1 is 3 factorial times 1 factorial. All right. So 1 factorial is 1. Again, that's not important. It goes away. 4 factorial is 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. So the 3's cancel, the 2's cancel, the 1's cancel. This is 4 over 1. So this is 4 times 3 to the 1st power is 3. 4, sorry, not 4. X to the 3rd power is just x to the 3rd power. So this is going to be 12 x squared. Okay. These middle ones get a little tricky here. So let's go. We've got 4 factorial over 4 minus 2 is 2 factorial times 2 factorial. Okay. So 2 factorial is 2. It's 2 times 1. 2 factorial is 2. It's 2 times 1. So 2 times 2 is 4 on the bottom. Okay. Then this is 4 times 3 times 2 times 1. 4 times 3 times 2 times 1. So the 4's cancel. 3 times 2 is 6 times 1 is 6. So this is going to be plus 6. So we got our 4 choose 2. Then we have our x squared. And we have 3 squared is 9. All right, cool. 9 times 6 is 54 bring down our x squared. There we go. We've got our first 3 terms. Just 2 left, and this one's super easy. All right, 4 choose 3. Let's check this out. So we have 4 factorial on the top. 4 minus 3 is 1 factorial. Okay, that's 1. That's going to go away. And then r factorial. That's 3 factorial. Wait, we've already done this one before, haven't we? Right here. These two terms switch sides, right? It's 3 factorial, 1 factorial, but they're multiplied, so that doesn't matter. So that goes away. 4 factorial divided by 3 factorial, that's 4. Okay, so we have 4. Bring down our x. And then 3 to the 3rd power is 27. Okay, we're so close. So 4 times 27, let's see, what is that? Plus 8, 108, yep, okay, x. Ooh, we're getting there, guys. Last one. So we have 4 choose 4. So that's 4 factorial over 4 minus 4 is 0 factorial. That's 1. And then r is 4 factorial. So 1, that goes away. Multiplying by 1 doesn't do anything. 4 factorial over 4 factorial, they cancel out too. This is 1. So we've got 1. X to the power of 0 is 1, because anything to the power of 0 is 1. And then 3 to the 4th power is 27 times 3. So that's 81. So 1 times 1 times 81, this is just 81. Okay, there we go. This is our answer right here. Let's bring this piece down. There you go. We've got our answer. And now you're going to think, Barton, if you make me do that, I'm going to shoot my dog. Don't do that. That's animal abuse. It's animal cruelty. It's just math. Don't be scared. Think of it like working out, okay? It's going to take some time. You can't go to the gym for 2 minutes a day and think, wow, I'm going to get so jacked. You got to go to the gym for like an hour. You got to sit there and you got to pump out them reps. These are reps, okay? They hurt. They're going to burn, but they're good for you and they make you healthier in the end, okay? Don't trip. So the hardest part here, honestly, is doing these chooses, but we just saw it. Not that bad. All right. So now that you hate the formula, let's go look at the other way to do this. The other way to do this is using Pascal's triangle, and I'll go back to that other one and show you what's going on, right? So Pascal's triangle is a cool thing that's kind of fun to fill out. It's kind of neat, right? So Pascal's triangle starts with a 1 on top. The boxes below are made of the sum of the 2 boxes above them. Okay, so like this box here, the 2 boxes above it that are touching the top of it are this box and this box. You feel me? Okay. So we start with 1. This box doesn't have a box here, so that's nothing, and this is 1. So you add the 2 boxes together. So nothing plus 1 is 1. 1 plus nothing is 1. Cool. That top piece is boring. Let's look here. Nothing plus 1 is 1. Oh, here's the first interesting one. 1 plus 1 is 2. And then 1 plus nothing is 1. Tight. Keep going. Nothing plus 1 is 1. 1 plus 2 is 3. Wow. 2 plus 1 is 3. And then 1 plus nothing is 1. Okay. So these are how we make Pascal's triangle. These are actually going to be powers of 11. This is 11 to the power of 0, 11 to the 1st power, 11 squared, 11 to the 3rd power. That's one way you can think about them. There's a bunch of different patterns that go on with Pascal's triangle. This is an interesting triangle. But anyway, so we finally start filling out some interesting stuff here. This is the one I want to show you because this is the one we just did, right? Let's go back and look. I hope this is the one we just did. Yeah. Okay. So let's look at our chooses here, our choose operations, our combinations. So 4 choose 0, that was 1. Okay. 4 choose 1, that was 4. 4 choose 2, that was 6. 4 choose 3 is 4, and 4 choose 4 is 1. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. Crazy, huh? So the row you use is determined by n. This is n equals 0, n equals 1, n equals 2, n equals 3, n equals 4, and so on. N equals 5. So because our n was 4, these are the coefficients you use for your combinations. 1, 4, 6, 4, 1. The next one would be 1, 5, 10, 10, 5, 1. Right, and then this triangle literally goes on forever, right? We could keep going if we felt like it. I'm not going to fill out all this because it's a lot, but these are your coefficients from those combinations, and this should speed up the process a little bit. Okay, so let me show you how to use this, and then we're going to do an example, right? Okay, so we want to expand this thing. So the first thing we need to do is figure out which row of Pascal's triangle are we going to use. Well, we already know because I chose the same exponent, but here are your rows. This is n equals 0, n equals 1, n equals 2, n equals 3, n equals 4. Okay, so we're going to use this row. So our coefficients from the combinations are going to be 1, 4, 6, 4, and 1 again. We still need to know a and b. A is 2x, b is negative 3. So this is going to be a to the 4th, b to the 0. This could be a to the 3rd, b to the 1, a squared, b squared, a1b cubed, a to the power of 0, b to the power of 4. Okay, so this is going to be 2x to the 4th power, negative 3 to the power of 0. This is going to be 2x cubed, negative 3 to the 1st. This is going to be 2x squared, negative 3 squared. 2x, power of 1, we don't need to write it, negative 3 cubed. This is going to be 2x to the power of 0, but anything to the power of 0 is 1, and then negative 3 to the 4th power. There we go. Now we just simplify these. So negative 3 to the power of 0, that's 1. So 1 times 1 is 1. So we just need to do 2x to the 4th power. So that's 2x times 2x times 2x times 2x 4 times. So 2 to the 4th power is 16. X to the 4th power is x to the 4th power. There's our first term. All right. Negative 3 to the 1st power is negative 3. 4 times negative 3 is negative 12. Then we have 2x to the 3rd power. So 2 to the 3rd power is 8. X to the 3rd power is x cubed. So this is going to be negative 96 x cubed. All right. Negative 3 squared is 9 times 6. And then 2x squared is going to be 4x squared. So 6 times 9, that's 54, times 4, that's 216 x squared. All right, now we're getting into some bigger numbers here. We have negative 3 to the 3rd power. That's negative 27 times 4. That's going to be negative 108 times 2. That's negative 216. Bring down our x. Oh, crazy. Look how those match. That's interesting. I don't know that always happens, but it does in this case. And last one here. Negative 3 to the 4th power, that's positive 81, times 1 is still 81, and then 2x to the power of 0, anything to the power of 0 is 1. So this is just plus 81. There you go. That is your expanded binomial. Cool? Awesome. So there you go. there are your notes. There's two different ways that you can expand things out. Let me know if you have any questions. If you're struggling with that formula, let me know. I can probably do a couple of examples with you folks in the WebEx or something. But try not to be too scared. Don't worry. You're just going to get your math practice in for the day. Until next video, don't forget to like and subscribe. Remember, only 72% of people... No, not only. 72% of you aren't subscribed yet. What's wrong with you? Go subscribe. Click that bell icon for notifications. I'll see you next time.